So with that, I'd like to introduce the innovation panel. For those of you who haven't seen this before, what we do is we ask various people and vendors to think about something that could change the whole industry, that could be very disruptive, or something in their area that they think is likely to change what's going on in the industry. And to do it very concisely, what we're looking for is, as opposed to very large detailed presentations of the technology or the details, really the concept, the idea, and how it could impact everything. And with that, I'd like to start with Altair. Nothing special here, it's alphabetical we ask each person to introduce themselves as they go along. Okay. This one here to start with? That's perfect. Okay, and if you can introduce yourself.
Yeah, Devin Jensen with Altair. Been there about 14 years now, and I'm a vice president of operations. And I'll just give a quick plug for the presentation from GE tomorrow, which we'll have our chief officer present that. Okay, something very succinct and groundbreaking. First, I want to say something about the museum. Since Altair is based in Detroit, Troy actually, we've done our own events at the Henry Ford Museum. So I highly recommend as you're drawn in down the line of presidential autos to the train, leave time for the opposite corner where they have the small house built. It's a circular home built after, I think it was World War II, for just modular. It's fascinating. An entire home that's off in the other corner. So leave time for that. So marketing knew that I had 5 minutes. So they gave me 10 slides. That was my reaction. So I'm just going to do one. There is a build to it. But the idea has been around for a long time. In the 1970s, it was called a network operating system to make one big computer. And in the 1980s, it was distributed operating systems. You remember the VAX and all that. And the idea was to make one big computer. And in the 1990s, networks of workstations and clusters. And around 1995, we did our first grid across NASA, across the United States. And that was before the word grid got, what's the word? Buzzword, right? And then, of course, in 2010, what's it called? Yeah, make one big computer. So what's new and exciting about our message here is, I think it was around 2006, we did our first, I guess you'd call it a cloud. It was bursting a large aerospace to, it was actually an HP environment. And we've done many since. Large oil and gas in 2015 had us burst them to Azure and so on. What's new? In June, we released a product that it's all there for you to just click on and do. Azure, Amazon, all the big names are there. And that is your ability to cloud burst. And I could demonstrate that, but instead I'm only going to do 45 seconds of another demonstration. Let's see the video here. This is it. All right, this is one of your users, okay? One of your scientists, one of your engineers who wants to do engineering or do science or computational chemistry or whatever the case is. That is kind of grainy, isn't it? All this user wants to do is submit his job to the high-performance computer. If anybody, you don't want to blink here because you'll miss it. If anybody has seen this done anywhere else, please let me know, because I think we're the only ones. It's such a novel idea. We did this demonstration. It took 90 seconds last year when it was in beta. This one's, obviously going to take 45 seconds. The audience was 600 engineers, okay, all Altair employees who work on site at Honda or Boeing or whatever the case may be. And when they saw this demonstration, that was the loudest applause of the week, because of what it meant for their productivity. So here's the play button. I don't think there's any audio. So all the user is doing is taking his job, whether it's a radios optimization or whatever, he's right mouse clicking and choosing process with, and an administrator can add some options there, process with 4 nodes, or, oh, there is some audio. But that is the extent of the presentation. Obviously there's another directory that comes up, it tells you that the job is submitted. There's even a job execution directory that pops up here, and that's when I was going to stop the video at 45 seconds. This was a live demonstration we just did Friday for a large conglomerate that was mentioned earlier in these slides. Someone who decided to cut their name to 3 letters. All right, that's enough. Thanks for your time.
Yes, they're all.
And then if you want to use the clicker, this should go forward,
Okay.
backwards, and laser.
That's okay.
Okay, great.
Thanks. Hi, I'm Derek Boyce from AMD. I'm a product manager for the AI computing space, really focused on GPUs, work in the Radeon technology group, and right now there's a lot of interesting things going on, and I wanted to, as mentioned this morning, about GPU acceleration and HPC. And what we're seeing is a lot of CSPs are asking for servers with multiple GPUs in them, up to 8, 16, even larger I've seen requests for. But they want to be able to use this in a very flexible environment. They want to reconfigure them over time. So they have, usually dual CPU, lots of memory, high-speed interconnects for node to node. And then the software becomes a configuration nightmare. So there's many different deployment options. The first one being bare metal. So some CSPs do that, provide you with your application that you can run. It's very closed. When they're providing services, they like to use virtualization. That way they can start and launch other operating systems as needed. And then container deployment has been around for a little bit and is gaining steam in terms of real workloads. Now the tricky part here is most of this has been designed for CPUs and many CPUs, not necessarily GPUs. And so the abstraction between the GPUs is always difficult, especially with binding in containers. And so just recently, Kubernetes has added some more concepts in extending that with device plugins. So AMD has a device plugin, NVIDIA has one, there's Intel-based plugins. Those are very useful for tying 2 or 3 GPUs to one specific workload. With the Docker container, there's other cluster management things. Kubernetes is maybe a common one in HPC. There's also Singularity. With Docker, you end up with a nice method to put your application all in one spot, but that doesn't work if your compute infrastructure is heterogeneous. So if there's many different types of hardware systems all within one infrastructure. And so one thing that we just released this week is called HCC2, and this is a concept we're looking at to enable flexible containers, and it's like a wrapper for all the different ways you can program a GPU. So OpenMP 4.5 or later, OpenCL, HIP, or CUDA. And you can then take this code, create one large, think of it as a fat binary, and deploy it across your infrastructure and run and have it determine what hardware is supported and available. So this could support even different CPUs, different GPUs, different FPGAs. It depends on your acceleration technique. And I'd be interested to talk to you guys tonight about what you see in the industry as OpenMP as a methodology. I know there's lots of debate about what's the MPI strategy for HPC. we spent more time recently in the deep learning space and frameworks with TensorFlow and Caffe and PyTorch, and they have sort of a more common understanding of what the infrastructure looks like and a nice abstraction layer. In the HPC community, there's a lot of people like to get down into the nitty-gritty and say, okay, I want to optimize with MPI to connect between devices. And the debate is, which is the proper way? Where do you want to spend your more time solving your problem? How can you divide out your data or your model? And so I'd say there's lots of different ways that can happen, and it's application specific. But feel free to approach tonight while we talk at dinner, and we can have some open conversation about what we see as programming models that are available in this space. And that's all. Thanks.
And next from Penguin. Or is this the old version?
Yeah, I think that's the old version. Should be on the desktop, right there.
I think I already had it pre-loaded this way.
Yeah.
And this will take you forwards, backwards, and a laser.
All right, good. Thanks a lot, Earl. My name is Sid Mayer. I run Penguin's Federal Systems Group. But today I'm actually going to talk about two things. I added a slide on Penguin on Demand just since we had so much heated or good discussion about cloud. So, but first, what I'd like to do is just talk a little bit about Penguin real quick, because some people in the room may not know it. Penguin has traditionally been a privately held company. In June, late June, we were acquired by Smart Global Holdings. We've been growing at about 40% year over year combined aggregate growth for almost 7 years now. And to fund that growth, it's always a challenge to continue to fund it as a private organization. Smart came to us and said they wanted to acquire us as a wholly owned subsidiary. What that means is that we were basically a bolt-on within their organization. There's no reorgs. Our company stays identical to the way it is. We gain a lot more capital, and we're also now publicly traded on NASDAQ as a SGH. So just wanted to give you an update on that. If you have any questions about that acquisition or anything, feel free to pull me aside and ask any questions you may have. So, delivering end-to-end AI capabilities. One of Penguin's fastest growth areas is our AI practice. We basically are in the process of designing and building GPU-accelerated computing systems, building balanced AI systems. I believe we have the largest InfiniBand-based AI cluster in the world right now at 860 DGX-1s. In one InfiniBand environment. That environment also has an additional 128 system cluster as well. We manage both of those from the application all the way through to the systems. And in the case of the 860 node cluster, we also host that for our customer. So pretty good sizable. I haven't heard of anyone having anything close to that size in an AI cluster. Last year, we were NVIDIA's Partner of the Year. We grew over 778% in NVIDIA business over the last 4 years in the AI and in the general GPU accelerated space. Let's see, this kind of gives you an idea. This is a real busy slide, and it's meant to be busy. We have the most complete line of GPU accelerated products from 1U pizza box type of environments that can go up to 4 GPUs inside of it, to the DGX2 and IBM's Power AI. All of them are offered in our product line, and we're providing solutions according to the needs of our customers across a wide range of both 19-inch as well as our open compute platform based on Tundra. Basically what we do in the AI space is we take Penguin's proprietary computing and storage technologies based on open technologies in general. We add in IBM Power AI Enterprise and Spectrum Scale or NVIDIA DGX1s and DGX2 environments to provide a complete AI solution to our customers. All right, I'm going to transition real quick to Penguin on Demand. There were quite a few questions, and I also think some things that I'd like to clarify in the cloud space a little bit. First off, Penguin on Demand is a hybrid cloud offering that offers virtually identical capabilities for on-prem and cloud workflows. One of our partners, Altair, we use your schedulers. We use the same schedulers that you do in on-premise. We don't necessarily require you to worry about hypervisors and that type of situation. You get bare metal in the system. Today we have about 25,000 cores available, and you can run up to 12,000 Skylake cores in one job at the moment, and we'll grow to 18,000 cores coming up. We do offer core hour volume pricing, and the big thing that we do is we offer basically very, very small incremental billing. So you're not charged a core hour or a core minute the moment you get on and run a system. You're charged in 3-second or less increments as far as the amount of time you spend within the environment. The other thing we do is we don't charge anything for data movement. Now, we do have some specialized charging if you need specialized data movement, but in general, we don't charge anything for movement in or out of the system. And we have specialized PhD subject matter expertise, as well as a lot of support that you would normally see in high-end organizations to make sure you're able to run your codes and port those codes over. The last thing I'd like to mention is, I believe it's upwards of over 300 ISVs now run in pod. Some of them you can use licensed servers that you have either on your own premise or to their licensed services as well. It depends on the ISV as far as what that agreement is. So we have been working with a lot of the ISVs to work through that issue as far as ISVs are concerned. And the last thing is last year we were Intel's 2017 Cloud Vendor of the Year that we were awarded in March for some of our capabilities. Thank you very much. One other thing, GTC DC, don't forget to go. We're a platinum sponsor, and we're really looking forward to anybody that's in the DC area to make sure you see us at GTC DC. Thank you.
Great, thanks. Next we'll hear from Panasas. Do you have slides here?
Yeah, there should be.
Oh, right here. There we go.
Yeah.
I know I had seen them. Hopefully this will. So I should give you forwards, backwards, and a laser.
Thank you.
Good afternoon. My name is Dale Brantley. I've been with Panasas for about 8 years. I've been in HPC, I think, well, before HPC was HPC, people who go back to control data days many years ago. I'm continued to be amazed at what comes out. You know, we say this will never happen, the cloud will never happen. It seems to be happening. At least there's some debate whether it's happening efficiently and cost efficiently as well. So what I'd like to talk about just a little bit today is what Panasas is doing somewhere in the simulation area. We actually have been in manufacturing for a number of years. Our first customer, which was Boeing, started in 2006 with us and continues to buy from us every cycle. Some of the applications that we see primarily are the CD APCO, CodeStar CCM, ANSYS Fluent, and we're seeing a lot of OpenFOAM today. We started seeing OpenFOAM in Europe about 2 years ago significantly. We're seeing it more and more, and it's also, we're now seeing it in North America, in the US in particular. The reason typically open foam shows up more is it has a different I/O pattern. So with the file systems, it's very key to understand what the I/O patterns are for these applications. Open foam happens to be dominated by small file I/O, which is quite different than the other applications, the main commercial applications. Some of the customers, the ones at least we can talk about, let you look at it real quick, but in addition to these mainline manufacturing customers, we also see a lot of customers, small organizations that are actually doing consulting work with Panasas. So they actually purchase Panasas storage, a small, typically a Dell cluster. You know, it may be 50 nodes, 40 nodes, that type range with a couple of shelves of Panasas, and set up a consulting company. And they may be using open foam, they may be using Star CCM or Fluent. So what makes Panasas work in that type of environment is it works out of the box. So I've done many installs. People say, well, how much tuning do you have? Do you need to take a week for tuning? And no, that's the case. It's not the case at all. We come in, we set it up, we do some initial testing, and we're ready to go. We actually have a hybrid design that actually stores the small files primarily from open foam on the SSDs. We've actually, in our last product announcement at Supercomputing 17, we announced a new product that actually had 1.9 terabyte SSDs in each blade. Why? It's because we're seeing so much growth in the open foam area. All of the Formula One teams, I think, now have switched to open foam. There's some financial implications for those teams why they did it, but the net effect on the storage is that it does have a totally different I/O pattern. So streaming parallel file systems have to behave a little bit differently in that arena. Management, simplicity, lower costs. Again, a lot of these companies that we work with are small organizations. There are no IT people. There's system admins that have a little background. They can boot systems, things like that, but they're not core HPC gurus that know the ins and outs of parallel file systems. So, having an environment that lends itself to easy use environment, replace a blade, bring the system back up without any problem really makes a big difference. Enterprise reliability, being able to maintain a system no matter what, and scalability. A lot of these smaller companies will start out with a couple of shelves. They'll go to always typically they'll go to more cluster nodes, and then cluster nodes obviously requires more I/O capability. So being able to scale linearly without having to do forklift upgrades is very key for our customers. Some of the customers that we're seeing, again, manufacturing, university is always a big push for us. Government, life science is a new one. Media entertainment, especially around the active archive. One of our largest customers in the U.S. is Turner Broadcasting. It's not an HPC play per se, but if you look at the big data component of what it takes to run 36 channels, that is big data. Especially when you talk about they deliver it on every one of your devices as well. And how many devices are there? How many different formats are there? So having that capability as an active archive is very key. And then, of course, moving on to new use cases, precision medicine, autonomous vehicles, artificial intelligence. This is, pretty exciting things that we're trying to prepare for once things start settling down a little more. Supercomputing 18, got to have a plug for SC18, everyone. We will be announcing a new product. So come see us. If you'd like to set up a meeting, let us know. We're more than happy to set it up. And finally, this is, I've enjoyed being here. I enjoy every 6 months or so. We look forward to coming here and appreciate the organization. Thank you.
Great, thank you much. And then Rescale's next. That guy.
Thank you. Before we start, I can tell you that this is result of soccer, and maybe I shouldn't be playing, but I am. I have a tendon that needs a boot for a few weeks.
There you go.
Ready?
Hi, everyone. I think I'll tell you, I think Earl wanted something slightly controversial. I think it's about time to rethink HPC. That's what I've been thinking for the last year. I spent 25 years with HPC on premises. I was with Cray designing operating systems. Then I was with SGI for a number of years running the HPC team. And for a year now in the cloud, and I have to tell you, a year at a startup in the cloud with Rescale feels like several years at a larger company. Things move like every week there's something new you have to go figure out. I've been thinking about this problem or this change, going from I have an on-premise system, I schedule my jobs, I'm fully utilized or highly utilized, I have to wait in a queue. What happens with cloud? And it's rethinking a bit of the world. And I'm not saying you have to move to the cloud. I'm saying we have to rethink how we can take advantage of my system on premise, other systems available someplace else. Remember the grid from 20 years ago? Maybe we can rethink that. And how about cloud providers that now Intel is selling more processors to cloud than on premises? All of that together makes me think there is a possibility to think about not the fact that I just have one machine and I have to run everything there. So what I've been doing at Rescale is Rescale has a platform, and the platform is this little window where you can come in as a user and say, I want to run an application. I don't know where, I want to run an application. Rescale has 300 plus applications ported and tuned to run on top of multiple cloud providers on-premise or different supercomputing centers or bare metal providers. So the interesting thing is you as a user want to run an application. You may want to run ANSYS, Computational Fluid Dynamics, Fluent. So you select, I want to run Fluent. And then by having run on all these places and having tune the stack, we're going to recommend where to run it. And maybe this job you're going to run on premise, the next job you're going to run in the cloud. And the advantage of doing that, now you have a pool of resources you can use and maybe not wait in a queue to always run on the architecture you have in-house that may be Skylake and InfiniBand. Some jobs may run just as well with Ethernet and maybe Skylake, or maybe a lower speed processor that'll be cheaper, but maybe you need large memory. So by matching the best architecture for the job, you can take advantage of something you could not before. So you have one way of submitting jobs, GUI for new users, that's something I hear a lot, or API CLI for advanced users. So the picture you have is as a user, I have a portal, I get a workflow, I say I want to run Fluent, it tells you these are the architectures you can run it on, but I recommend the one in the top. Click on it, tell me how many cores you want, you're going to start running right away without a wait. And we have customers today that are running, like in the auto industry, totally without a wait. And the advantage of that is they're accelerating the time to do simulation, the time to run. So you can run on premise, you can run in the cloud. So instead of waiting in a queue, you run them all in parallel. It's just as expensive to run all the jobs now than to wait in a queue when you're using the cloud. But also, you can take advantage of the best possible architecture for the job. If you need to do machine learning, you can use the latest GPUs. You don't have to wait 6 to 18 months to get the latest GPUs. You can use them now. But other jobs can be running on a lower cost. And that's the interesting thing, that level of matching for the best computing resources. So who are our customers? This morning you heard Mark talking about the computer going up with SpaceX. This manufacturer of rockets needs to do 100,000 simulations before they launch a rocket. They could do it on premises. It'll take them 3 months. By doing it in the cloud, they do it in days. So that's an example of I have my on-premise system, but I can use cloud. We have auto companies. We have big auto companies using Rescale in a hybrid environment today, and you're going to hear more as we make it public. But really, they're saying, for the next round, I don't want to buy another complete system. I want to move to the cloud because it gives me the flexibility to do that. Universities are using this idea. I have the platform for all the students and researchers to submit jobs to my system in-house, and that way I can also open up to cloud very easily with one way of submitting. I can take advantage of cloud. So I've been thinking about the problem of companies like aerospace and automotive for the last year, and we're working very closely with them advancing that. I've been thinking about industry and university government research. I wrote an article in the last week saying, we can rethink how we're using things in universities. Instead of having my one system that I'm using today, I can have the platform approach, collaborate with other centers, use cloud as appropriate, and there's plenty of challenges with doing that, but we can go solve them. There's questions about licensing today with some of the other vendors. One thing Rescale does is it offers pay-as-you-go licensing or bring your own license. The result is today, you can run in the cloud with pay-as-you-go licenses or open source for 33 out of the top 40 applications people run with us. So the interesting thing is, I'm just seating you in 5 minutes with, I think there's a change happening. I think there's an opportunity to rethink HPC. That is not the way we've always done it, which is machine in-house and you wait in the queue. But let's take advantage of the advancements of cloud, of licensing, of communication, of software platforms, and be a better result in terms of optimizing your dollars, performance you get, wait in the queue, etc. Time's up. We have time for questions or not? You said there was, but questions at the end. Thanks, everyone.
Yeah, I might have to unlock them. Thank you. So let's see. Right there. You already have the right ones.
Oh, that's right. You put the right one there.
Okay.
And then cue the point. Oh, yeah, point. So
Got
the
it.
top one gets you forward.
Great. Well, hi, everyone. I'm Cameron Brunner from Univa Corporation. I'm the Director of Engineering there, responsible for our engineering activities here in North America. My presentation is going to be on extreme scale HPC and specifically building million core clusters in AWS. And thanks to Will for his reference. Up higher? Okay. Thanks for his reference earlier in his presentation. So first with Univa, for you guys who don't know, we're a global software company producing solutions for cluster automation and workload orchestration. So with our flagship product, Univa Grid Engine, and our cluster automation solution, NavOps Launch, we manage pretty much at our customer sites 2.5 million compute cores and run approximately 7 million HPC jobs a day. And these are the types of industries and customers that we presently have. And so these are the folks who are really leveraging our software right now and also looking to us to help them move their workloads and expand their HPC clusters to the cloud. And to that end, we were asked by Amazon to put together a 1 million core cluster using our software to kind of demonstrate this extreme scale, both for our software and for the AWS infrastructure. So we put together this POC, which was released at ISC 18 this year, and also on our blog. And the kind of the summary of it here is we build a 1 million core cluster, and this is 1 million cores as Amazon calls them, so they're vCPUs. To do that, and to leverage all of those clusters, we brought them all together into one Univa Grid Engine cluster. So as far as we know, this is the largest Grid Engine cluster that's ever been built. We were able to get up to 56,000 instances, or right under 56,000 instances inside of this Grid Engine cluster. And it was then spread across one single region in AWS. So we weren't doing any type of VPC peering or any VPNs. This was in one availability zone. It happened to be in the AWS EU West 1 zone, so in Ireland, where they only have 3 availability zones in that region. So that really kind of stressed the capacity of AWS there, actually. So to get to our 1 million core, we actually had to use instances of 30 different types of compute instances. So we started with instances that had the massive number of cores, like 96, and we pretty much emptied out AWS all the way down to 4 core instances. So it was a very, very heavy simulation. And then the only way to be able to really do this in AWS right now is to leverage spot fleets, which is a new API that Amazon has for more or less specifying the compute capacity you want, the instance types that you are willing to take, and it just fulfills those. And that's the only way to really get up to this type of scale and be able to build a 55,000 core or 55,000 instance cluster in approximately 2.5 hours. So it's a little hard, I guess, to see some of these lines up here. But what's important to see is we have data up here, and I have another slide that will show these graphs a little bit better. We have data up here that shows the counts from AWS, and down here the counts from Grid Engine. Now, we had to build our own monitoring solution here because AWS couldn't actually handle the API calls with this amount of instances to give really up-to-date statistics. So what we're actually doing here is having instances report their state to Redis, to a Redis cache where we're accumulating those and publishing them as Prometheus metrics. So up top there, that's where you can see the 55,000 AWS instances that are up, the sum of all of their vCPUs, which we got up over 1 million. And then down here is the actual stuff in Grid Engine. So you can see Grid Engine knows about 55,382, and we have 1 million cores active to run jobs. And you can see right here is when we actually started submitting jobs to our cluster, we were able to achieve a linear submit and dispatch rate, and right there is where jobs actually started completing. So on to the next slide. I think this one's a lot more interesting because it shows the beginning of the run. And you can see how the change in instance types affected the growth rate. So over here, this is instance count by type. And then this is instance cores by type. So you can see here in the beginning, we only added, this is 10,000. You can't see it in there. But you can see we got up to, this is 400,000 cores. So in about 15,000 instances, we were able to do 400,000 cores. And this slight growth over here to get up to our 1 million, that's when we added the 4 core instances here. So, you know, really you can see how we got outside of the happy range when growing a cluster. But the goal was to get to 1 million, so we did whatever we could to get to 1 million. This right here shows all the different instance types that were participating at the cluster at this point. So really what I felt was really interesting about this, we met our goal, we were able to do 1 million. But what I thought was super interesting was, you know, maybe it's a lot better that you can do a smaller, like let's say 100 or 200,000 core cluster, get the really high performance instances, and really be able to leverage, you know, more of a traditional HPC environment, as opposed to mixing 96 core 10 gig Ethernet instances with, small 4 core instances that really don't have the interconnect. So I'm really interested in any questions that you guys might have about this environment, what we had to do to get there, and with that, we'll wrap it up.
Great, thanks. So any questions from the audience for the panel? Lloyd, we got one over here. Oh, you need a microphone.
Where am I going?
Cameron, what type of application were you running? Was it Monte Carlo or CFD?
Yeah, so for this one, is this on? Yes. So for this first test, we didn't have a lot of time. We only had about a month to put this together. So we only had more or less just a simple CPU spinning job, like, you know, nothing really accomplishing any real work. The fun thing about the cluster actually was, you know, we had to get special permission from Amazon to even bring this up. It would cause disruptions in their zone, and as soon as we got it up, we had to take it down. But it's showing you where they're going and what they want to do. In their region like US East 1, which has 6 availability zones, you know, they can handle this type of capacity. So yeah, if we had more time, I'd like to run more real applications, but in our example, we did not.
Just a quick question on that. How long did that million core system stay up, and how much did it cost?
So I didn't get the price of that one. We had the one right before that. We ran 2 days before where we got up to 800,000, and that one cost $70,000. It ran for about 2 hours. So yeah, the SC that I was working with was very excited about the bill that was being piled up on him at Amazon. So.
Okay, cool, great, thanks. My other question is for the gentleman, Derek from AMD. One of the things that's gotten a lot of publicity the last year from NVIDIA is the NV switch and the NVLink capabilities, the idea of they have a specialized capability to link their GPUs together. Is AMD working on something along those lines as well at this point? What are the plans for something like that?
Yeah, there are some plans. I'm not sure actually how much is public, but Supercomputing 18 will have lots of detail.
Okay, you're among friends here if you
Yeah.
we want to share. Hey, if no one's going to ask questions, I'm not picking on the gentleman from Panasas, but you're the only guy that mentioned SSD. Do you have any idea what happened on the spaceborne computer? Why would those fail?
I'm going to talk to him a little later.
Okay, cool.
I think all you need is aluminum foil.
It's always worked for me.
Okay, this is a wide question for anybody who has an opinion on cloud. If you had to characterize it, are we a quarter of the way there where we're going? Are we halfway there, or have we not even gotten started?
That slide that I showed you was created for a supercomputing event in Mexico in 2010. Does that answer your question? We've come a long way. Whether we're halfway, I doubt it. So that's more.
I think for the potential of the market, we're extremely early. I think the market is going to grow tremendously over the next several years as you provide services that are more in line with what people are doing on premise and are able to provide cost effectiveness to that. And like people have said, it's not necessarily cost effectiveness on pure price. It's cost effectiveness on your time to solution. One of the things we do at Penguin is we've got a half a dozen production environments that have to run every single day at the exact same time over and over again that could mean millions of dollars to that user. So, you know, it's being able to provide that kind of queuing that you know you're going to provide the production that people need on specific times. And we have a variety of different ways of doing that for our customers. And then, of course, general HPC queues as well. So I think we've got a long ways to go. It's going to become across the entire marketplace, I think, not just what we think of as traditional HPC.
I'll add one more comment. I think for the new economy people, they go to the cloud. Startups come straight to us. They don't want to buy hardware. We have a company, Boom Supersonic, is designing the next supersonic plane, and they're doing it totally in the cloud. They're doing CFD. They're designing the complete plane totally on standard public cloud providers using Rescale. So that defined my mind when I arrive at Rescale and I see that happening. People are thinking the cloud is for single node jobs, but these people are designing complete planes and doing flight simulators and everything totally in the cloud. So new economy is that way. Traditional HPC is 95% probably on premises. So that shift will need to happen. I don't think it'll happen overnight. I don't think people just move to the cloud. I think they're going to start testing cloud, and they are. Steve Conway was saying that I think last year 2/3 of the companies were testing cloud, but not going very deep. And I tell you what the challenges I hear are, what's the cost? And we heard some of that today. I don't think the cost has to be how much is a cluster on premise versus the same cluster in the cloud. I think you have to compare what's the cost of running my workload with a system on premises and what kind of service do I get versus what's the cost of running the same workload in the cloud and what service do I get. So to me, that's an interesting distinction between a cluster here and a cluster there. Sometimes I say, if you're going to compare buying a car versus using Uber, you're not going to want an Uber 24/7 at the door waiting for you. That's going to be more expensive. So think about the utilization, think about the service you get and how much you pay for that. We have customers that are totally in the cloud. We have customers that are hybrid. And then the other thing that needs to change is the perception of security. People worried about putting things in the cloud. In the IT world, it seems like people worry about putting customer data in the cloud until Salesforce appears and everybody puts customer data in the cloud. So I think it's the perception of the cloud. Cloud is very secure. Places like us have security teams that fix patches every day better than people do on premises. So as long as people are happy with cost and security, you're going to see people start moving and they get the advantage of no wait and faster time to market. Other people are going to copy them. To me, it's like I lived the Linux revolution, right? Linux was nothing, it was a toy operating system. We look around, 30% of the web servers were Linux one day. What happened? So I think we're going to see people moving in steps. So it's hard to say where we are. I think we're going to see movement in different parts of the industry, and suddenly we're going to look around, there's going to be a lot of cloud. That's what I sense.
I'd like to just add one last thing to that too as well. I mean, I totally agree. From our perspective, we've been offering a cloud product since 2009, and the changes in the last year are really significant. So it seemed like pretty slow interest, but we're seeing a lot more interest in people looking at what you consider traditional HPC workloads and people looking at moving those to the cloud. Security is a big part of it. Now, the security infrastructures that people are looking to put into AWS or something like that to facilitate this are way more complicated than what anybody was talking about a few years ago. So I don't know where we are, like everyone else has said, in terms of agreeing, but we're definitely ramping up. That's certain.
Any other questions?
So, if I heard you right, you said $70,000 for
It was
2 hours?
about 2 hours.
So I did
2 or 3 hours.
I did a quick calculation on that, and I assumed a system that was used 16 hours a day.
Mm-hmm.
And to get that amount, well, the annual cost for that system via the web would be $204 million.
Yes. Yeah. So I know, are you interested, why would somebody want to do this? Is
Yes.
that what you're,
Yeah.
So what I have heard is use cases where, a potential use case for something like this would be a workload that needs to run in a short amount of time, periodically, but, never, around the clock. Consider something that needs to run like when all the markets are closed, or between, New York and Tokyo being closed. Something that has to get done there to do auditing or something along those lines where, a big enterprise doesn't want to have the infrastructure, but needs to get that work done. So it's definitely not, what you would consider 80% utilized cluster. This would be a horrible way to go around doing that. Also, you probably wouldn't want to throw in, of the ones that you include in that million to get your performance, you wouldn't want to throw in the probably last 500,000. The first 500 of the higher performance stuff would be the way to go. So I don't think it would be the most efficient use of it, definitely in a 24/7 cluster.
I have a philosophical observation, is that I don't agree with your calculation because this calculation is for the owner of the hardware. For the cloud provider, they have to make their maths about having all of this amount of resources, maybe being idle. But for the user, I'm only going to use it 1 hour. Mm-hmm. So the point is that I, as a user, sometimes it's like was said, it's like comparing the cost of having a car versus Uber. So you compare 24/7 having a Uber is very expensive, but okay, you only will use once. So the question is, as a user, to me, having something and I don't have to wait 1 year, and I have it in 5 minutes, in my business, this is billions. Because this is the decision of making a dry hole or successful well, for instance, in our industry. So the opportunity of having things instant or in 1 hour instead of 1 year is unbelievable in a business perspective.
For the million core run, a couple of questions. The price, was that the on-demand price?
No, we were using spot fleets, so their spot instances so we set the price level as high as you could set it because our goal was to gather as many instances as we possibly could. Some of them would have been at the lower price, but we would be paying some at full price, I assume, since we saturated the whole region.
And then more critically, who's paying for the resource time when they're being marshaled before you have all million cores. Are you being charged for that, or is Amazon paying for that? Because if this is common and they're paying for it, they're going to likely raise their price because that's resources out of action for a long period of time.
Right, and I don't know what their answer to that question was. In this specific case, it was a partnership with Amazon, so it was, they were more or less comping the resources. It wasn't something we had to pay for. In our environment, it matters really what type of HPC workload you'd want to run on this thing. The fact that with using spot instances in Spot Fleet, you have to tolerate instances coming and going, which aren't necessarily great if you're running HPC workloads on them. An instance terminating while running your work is not great. So we were waiting till things were kind of more steady before submitting work to kind of just erase those situations for our test. But ideally you would want to do something that could handle that, and then maybe you could start submitting jobs while it was building, and then kind of ramp up to your full capacity once the nodes get there. I do know AWS is actively working on improving the Spot Fleet grant rate, so you'd be able to get, and I can't remember the number specifically, but the number of instances that you can get per minute is going to be really quite large in the near term, so that building like the 100,000 core cluster could be done in 10 minutes. And if you have the quota too, right?
Out of curiosity, how long do you think it would take to upload say a petabyte seismic volume to the cloud?
Well, I don't think anybody really wants to do a lot of uploading. I think for something like that large, it's normally the different services have options where you can mail them a hard drive. So that's usually faster unless you have a really large pipe. Does that?
Actually, we just did a test, a petabyte in 24 hours.
Wow, yeah.
So
there
but
you go.
it is a specialized solution. And by the way, we do charge for that data movement.
Yeah.
But we have a product line called Excellion that basically gets about gains you about 95% of a bandwidth of a normal network connection, wide area network connection.
Mm-hmm. So you had incredibly compressible data?
Nope, it was not compressed. So I can talk to you later about if you want to come to and talk about the product line. It's a very interesting product line. It does use multiple networks at the same time, but we moved it across the United States in basically 24 hours.
I have a comment on loading seismic data in the cloud. First of all, you're not going to load 1 petabyte in the cloud through internet connection. Mm-hmm. So you want to load that amount of data, you load with a track, because you can do it. Mm-hmm. The same way that you will be loading in your data center. Now, for the practical use of loading in the cloud to process, we do the following thing. In our daily production in the field, which is several terabytes per day, so we compress 300 times based on our wavelet compression algorithm, which is very good. It's lossless compression. We transfer overnight with the satellite. It's in our data center, and we start. So we load all daily production. We are processing. So it's immediate. It's not only that you have to finish the survey and everything you can do immediately. And the time that you are saving in your projects is huge. So this is the point. I mean, maybe you say, no, I have to reprocess a petabyte. Okay, in this case, what you have to do is with a track. All the three. You say, oh no, it's a production survey, which is big data, it's a lot of data. So you can do it. Daily production overnight.
Not so much a question as a statement. Nothing has changed. I worked for a company that 30 years ago had a Cray 2, which cost $25 to $30 million. And it was basically in the timeshare business. And a lot of oil companies would package up their data, put them on tape, send it up, get processed on the Cray 2, and take the data home. And that was it, because it was a very expensive machine, and they weren't going to utilize it 24/7. And so the same thing applies today with the cloud.